All right, hi everyone. Now we're going to go on to how do you factor with using difference of two cubes and sum of two cubes. We just covered difference of two squares. So again, going back to this factor man or factor woman, if you first you find the GCF, and then if there are two terms, such as these problems, notice all these have two terms. We do not group, we do not Xbox, but we do what we look at here with two terms. So we're going to look at it, is it a dots, a doctica, or a soctica? So go ahead and fill this out as I go through this, and we'll do three examples. So here we just learned dots, the difference of two squares. So we ask ourselves, is it the difference of two square terms? If so, then when you factor it, it is this formula here. And I showed you guys in the previous video that this is not just come out of thin air, nor does it take Einstein to figure that out. You just multiply through and we end up getting that. The difference of two cubes, so again, I just love mathematics because the name of the method really describes what it is. So you don't have to like memorize words that make no sense, right? So the difference of two cubes, meaning you have two cube terms, right? The cube, that's why there's a 3 on them, and it's a difference. So you subtract. So if a problem, say one of these problems, falls in this category, the difference of two cubes, then the formula would be a minus b. Okay, so it's a long formula, just warning you. A minus b, then a squared plus ab plus b squared. And yes, you're required to memorize it, right? So it's going to be this here. And again, how did they come up with this? Well, if you multiply this through and you do all the distribution, you will end up with that. And for the sake of time, I'm not going to show you that proof, but you could just check it on your own time if you would like. Now the sum of two cubes. So again, two cubes, so a cubed, b cubed, and you're going to do the sum of it, and the sum means addition. So a cubed plus b cubed. The formula. So the nice thing is the formula looks just like the one on top, just with a few minor changes. So instead of a minus b, you're going to do a plus b, which is nice because this was a sum, right? A plus b. And then it's going to be exactly the same thing on top, except you're just going to change that sign to a minus. So this is a plus here, then this becomes a minus here. Similarly, if this was a minus here, then this becomes a plus here, just to help you memorize it. So these are the three formulas, really important formulas for you to know to do this problem. To do these problems. And actually, I am going to change this to a plus here, just to, because I notice all these are on minus. I'm going to change that to a plus. All right, so let's look at number 17 here. So 17 here, first I ask myself, is there a GCF? So is there a GCF here? 48 and 27. This is an odd number, this is an even. So right now they don't have anything in common off the top of my head. So the answer is no. And I see there's a z cubed and a z. Oh, actually, I just thought of something. 48 and 27 does have a common GCF of the number 3. So yes, 3 is a GCF because 48 divides by 3 evenly, and then 27 divides by 3 as well. So great. And then there's a z cubed and a z. Okay, they both have a z in common. So we talked about this on the first lecture about how to find the GCF. So if you need to review that, please feel free. So z, so they both have a z in common. So right now I'm going to rewrite this with the GCF on the outside, right? So the GCF is on the outside. I pull out the GCF, and then I'm going to write down what's inside. And of course the inside, since there's two terms, there's also two terms here. So 3z times what will give me 48z cubed? So 3 times what will give me 48? Or in other words, what's 48 divided by 3? And the answer is 16, right? So 16 times 3 will give me 48. Z times what will give me z cubed? Z times what will give me z cubed? Well, this is a 1 here. Then using the product rule, you need to add the exponents. So when you add the exponents, 1 plus 2 will give you 3. So again, if you're kind of weak on that, make sure you go back to the previous section on exponential rules so that you can get good at doing that. The second one here is 3 times what will give me 27? Or in other words, 27 divided by 3 will give me 9. And then since it's already a z here, I don't need to put a z there. And I always take this moment to double check my work because I tend to make minor mistakes by just distributing through it to make sure I get the original. So 3 times 16 gives me 48. Z times z squared gives me z cubed. 3z times negative 9 is negative 27z. Perfect. Am I done? I just factor, right? Am I done? And the answer is no. Because this dude says factor me to death or factor completely. So factor all the way. So when I look in here, I'm like, can I still factor this? Well, let's check. There's 2 terms. Okay, 2 terms. What do I do? It's either a dot, doctica, or soctica. Well, which one is it? Well, this is a minus. So since it's a minus, I know it's going to be a difference, right? So that takes out the sum of 2 cubes. It's not that one. So it's either the difference of 2 squares or the difference of 2 cubes. Well, I see here z squared. Z squared tells me, oh, maybe it's a square term because it's z squared, right? So maybe it's a square term. So I ask myself, I have a hunch that this might be a square term. So if it was a square term, what is being squared? So what is being squared if this is a dot? So is this a dot? And if it is, then what is being squared? Sorry, this is so ghetto. Okay, so what is being squared? So here, 16z squared, well, what's being squared? 4z is being squared. What is being squared for 9? 3 is being squared. So because of that, I know, yes, it is a dot. So therefore, I could use that formula, 4z minus 3 times 4z plus 3. So here, I'm going to have, so when I factor, so this is my factoring step, right? This is just me double checking if this is a dot. And if it is, then I'm going to write it in the factored form, 4z minus 3, 4z plus 3. Is that my final answer? Am I missing something? Yeah, I hope so. I hope you said yes, because what I'm missing is I'm missing the 3z. So the 3z also goes outside here, and your final answer would be this. Okay. All right, next problem. This one here. So the first thing I'm going to do is there a GCF? So I hope I'm sounding like a broken record. I feel like I am, but that's a nice thing about math. It just repeats itself, right? There's nothing new and crazy about it. So I have 2 terms. What do they both have in common? They both have a 2. What else? Do they have an x in common? Nope. They have a y cubed and a y cubed here. So 2y cubed is a GCF. So I'm going to pull out the GCF. And then inside the parentheses, when I factor out the GCF, so like as we learned on Monday in the previous lecture, 2y cubed times what will give me 2y cubed? Just 1, right? 2y cubed times 1 will give me 2y cubed. 2y cubed times what will give me the second term? Well, I have 2 and 2 here. I don't have an x to the 4th. And then I have a y cubed and a y cubed there. So that works. That's good. So that's a GCF. So now I ask myself, is it a dots, a doctica, or a soctica? Well, again, it's a subtraction sign. So subtraction time tells me it's either a difference of 2 cubes or a difference of 2 squares. So it's one of these 2. So I ask myself, is it a cube or is it a square? Well, the number 4. X to the 4th power is even. So I'm going to ask myself, oh, maybe it's a squared. I don't know how to pick these problems. I don't know how they're all becoming difference of 2 squares. I should have given you guys a little bit more different examples, but I'll do that in a bit. So I'm going to ask myself, is this a dot? That's my hunch. That's the difference of 2 squared because x to the 4th is an even exponent, and even exponent can be squared, is most likely something being squared. So to check if this is a dot, I'm going to ask myself, is something being squared minus something being squared? Well, what is being squared for 1? Just 1. 1 squared gives you 1. What's being squared to give you x to the 4th? So x to the 4th, what squared will give you x to the 4th? And the answer is x squared. Because remember, using the power rule, if you multiply the exponents, you get x to the 4th. So here, x squared squared will give you x to the 4th. So therefore, when I factor this using the dots formula, I end up getting, right here, and I should use blue just to make it obvious, I get 1 minus x squared times 1 plus x squared. And don't forget to bring down your 2y cubed. All right, So am I done? Well, this is kind of a trick question. The answer is no, you're not done, because you want to remember, factor me to death, factor me all the way. So I'm going to ask myself, can I still factor these dudes? Here's 2 and here's 2. So can I factor them? Well, this one here, 1 plus x squared, 1 plus x squared, let's see. This is a sum, so here's a sum. So all these are differences, so I'm not going to consider that. That's a sum. Is it a sum of 2 cubes? X squared is not a cube power, so I would say this is not a sum of 2 cubes. So therefore, 1 plus x squared cannot be factored anymore. How about 1 minus x squared? So let me erase, I did my eraser. This is like me in class always losing stuff, right? So let me erase this just to make more space. So 1 minus x squared, can I factor this a little bit more? And the answer is, let's find out. So 1 minus x squared, so it's a minus sign, so I know it's either the difference of 2 cubes or difference of 2 squares. So is it a squared or a cube? Well, this is x squared, so therefore my hunch is it's probably a difference of 2 squares. So again, I'm going to check to see if this is the difference of 2 squared, and if it is, it's something squared minus something squared. All right, so let's check it. Is something being squared to give me 1? Yep, just 1. 1 squared gives me 1. Is something squared to give me x squared? Yep, x. X, when it's squared, gives me x squared. So yes, it is a dot. Dude, I'm doing so many dot problems. I didn't intend to do that. But anyways, if I did it like that, then when I factor it, using the formula a minus b times a plus b, it's 1 minus x times 1 plus x. Okay. So is that my final answer right there? No, right? So the final answer is, remember to bring this down, 2y cubed times this. And then don't forget this part, right? So this part was the factored of this. This is a factored version of this, but then don't forget this dude too. So I get 1 plus x squared. So after doing all that work, don't forget to bring everything down as your final answer. And this is your final answer for number 18. All right, so I had to find some other examples that actually use the difference of 2 cubes and sum of 2 cubes. So here are some examples. So number 19 on the Math 140 worksheet, 8u cubed minus 125. So again, 2 terms. Is there a GCF? The answer is no, right? 8 and 125 do not have anything that's divisible by both, and this is a u cubed and this doesn't. So there's no. Okay, that's fine, no GCF. So now I see 2 terms, so because it's 2 terms, I'm gonna go down the body to say, is it a dots, a doctica, or a soptica? So here, 2 terms, and I see a subtraction sign. Subtraction means it's a difference. So I'm gonna knock out the option of it being a sum, so it's either a dots or a doctica. So it's a difference of 2 squares or difference of 2 cubes. So when I look at this, I see u to the 3rd power. Well, u to the 3rd power is a cube exponent, cubic exponent. So I have a hunch that's going to be a doctica, a difference of 2 cubes. So doctica, that's how I write that. And this is soptica, and this is dots. Right? So I have a hunch it's going to be a doctica. So, a doctica is in the form where something cubed minus something cubed. So my question is this a doctica? Is it the difference of 2 cubes? All right, so when I look at 8u cubed, what's being cubed? So the number 8, what number cubed will give me the number 8? And the answer is 2. 2 times 2 times 2 will give me 8. U cubed, what's being cubed? The u. 125, what is being cubed to give me 125? 5. Awesome. So yes, it is a doctica. So because it's a doctica, I'm going to use this nifty formula here. So when I use this nifty formula, I'm just going to plug it in, right? So here, it's going to be something multiplied by something else, right? And it's going to be a minus b, right? So I'm just going to write it below here, a minus b multiplied by a squared plus ab plus b squared. Well, what is my a? This is my A. What is my B? This is my B. So A minus B, to write that, A minus B is 2u minus 5. A squared, what's A squared? What's 2u being squared? So 2u times 2u gives me 4u squared. Plus A times B, so 2u times 5 gives me 10u plus B squared. So B is 5, so when I square that, I get 25. And that, my friends, is the final answer. So it's not too hard in the sense where the formula is already given to you, and all you do is you just plug it into the formula and then you get it. It's just a hard part is actually memorizing the formula, right? But the more and more you do this, the more easier it'll get. Here's the